chat and put it here. That should be fine. Okay, let's close this up. I think I used to have a chat in my OBS as well. Let me see. It says everything is fine, but I don't have a chat here. Do I have a pop out here? Never mind, I'll just open up a new window, youtube.com. Let me see. And let's mute this so that not get feedback, and do open chat in a new window. Okay. I wonder if this works. Can I close this one? Yay, I can close the feed. Okay. Hello, Luke and Amate. Good evening. I'm just trying to manage a chat. I still need to build an overlay, so my apologies that I still haven't done that yet. I should probably make this a bit bigger, move it like this. This is the smallest that this one can get, so let's do something like this, right? Yeah, that works. Okay, we should be live on both Twitch and YouTube. It's still everything manual, so I still haven't done that, but yeah, it should be fine. Amate says switch to Switch, and Smap UK is here as well. Hello, and I think my daughter might be joining as well to watch me live, so that's always fun. So yeah, how is everybody doing? I think Luke said today wasn't that bad, so let's hope that we don't end up being here for another few hours. So yeah, gonna take a sip of my cappuccino and probably start reading today's question. Let's see. You find yourselves on the roof of a top secret Easter Bunny installation. While the historians do their thing, you take a look at the familiar huge antenna. Much to your surprise, it seems they've been reconfigured to emit a signal that makes people 0.1% more likely to buy Easter Bunny brand imitation mediocre chocolate as Christmas gift. Unthinkable! Amate says it was nice, no spoilers, okay. So the answer is 16. No. Let's see. Scanning across the city, you find that there are actually many such antennas. Each antenna is tuned to a specific frequency indicated by a single lowercase letter, uppercase letter, or digit. You create a map, your puzzle input of the antennas. For example, okay, so you have a bunch of zeros and a few A's. The signal only applies its nefarious effect at specific antinodes, based on the resonant frequencies of the antennas. In particular, the antinode occurs at any point that is perfectly in line with two antennas of the same frequency, but only when one of the antennas is twice as far away from the other. That means for any pair of antennas with the same frequency, there are two antinodes, one on either side of them. So for these two antennas with frequency A, they create two antinodes marked with hash. Okay. Adding a third antenna with the same frequency creates several more antinodes. It would be ideal for 4 antinodes. It would ideally add 4 antinodes, but 2 are off the right side of the map, so instead it adds only 2. Okay. So this one is the straight line from there. This one is straight there, there, there. Okay, so this one falls out. And which one? And this one and this one. Okay, so here and here they would fall off. Luke says I had to read that 542 times. Nice. Yeah, I think I get it so far. Antennas with different frequencies don't create antinodes. A and A count as different frequencies, however, so uppercase versus lowercase. However, antinodes can occur at locations that contain antennas. Okay, so you can, sure. In this diagram, the lone antenna with frequency capital A creates no antinodes, but has a lowercase a frequency antinode in its location. Okay, so the uppercase A, because yeah, that would be, sure. The first example has antennas with two different frequencies, so the antinodes they create look like this, plus an antinode overlapping the topmost A antenna. So this one here, right? That would be because of which two? Let's see. Oh yeah, this one. Boom. Sure. Because the topmost A frequency antenna overlaps with the zero frequency antinode, there are 14 total unique locations that contain an antinode within the bounds of the map. Okay, let me... this one I need to check what they mean. Notepad. Bloom. The description completely matches error theory by itself. And Mama Play says, hi! And I think that is my oldest daughter, MA. So, hi MA, nice to see you. Hi. It's nice to have her live here. So let's see. So that would be the hash. So I can probably do replace all with an equal sign, and that would be 14 matches, right? It doesn't actually say that. Okay, that's annoying. So I could do, let's do it like this. Actually, I could. Right, I could do hash replace comma equals. No? Okay, never mind. I'll find a way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sorry. 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, plus the one that isn't showing. So even though it's not showing here, it will still count it. Okay. Unique locations that contain an antinode. Okay. Calculate the impact of the signal. How many unique locations within the bound of the maps contain an antinode? Okay, so that is fine. This is doable. Famous last words, but let's see. So basically you create your own distinct... oh yeah, because it's day 8. I already forgot to change that on the YouTube thing as well. So everybody got a notification for day 7. Let's see. Day 8, and most importantly, update the base. So here is our test input. The answer P1 becomes 14. Okay. And now there's something that because I have something that lets me map them based on map all, right? This thing. At least, no, let me check, because for yesterday I think was it day 6? Yeah, day 6. Map as grip location, something like this. So what I have here is that I pause every char that needs to be mapped. I could still do that actually. But I just need to make sure that I map out all the characters first. So I would do input dot group by X. So this is a character basically, because this becomes a char, right? This is just a char array inside. To dictionary X count. So now we can do also a little write line here. So we can do for each var entry in var grouped dot order by descending value actually. So we want to do the most occurring first. Console.writeLine. So we can do blah this many times. So we have entry.key entry value. We can use all these keys to use this function to map them all out and get a sparse map of every single type. Then we just need to make sure that we adhere to the actual map location size so that we exclude all the ones that would fall out of that range. Let me see. I also need to make sure that we start day 8 and not day 7. So if we run this right now, it would spit out 3 values, the period, the zeros and the A's. So let me just show you. Let's run that again. So this is the sparse map. Is it? Oh yeah, period. It does the new lines as well. That's funny. So the carriage returns and the new lines, I should trim those out. And then it shows it has 4 of this one, 4 of that one. So if we do dot replace, we do string replace actually, because we go from a different length. So we do \r. Actually, we can also just do by this, where x not equals r dot key actually. And x dot key not equals \n. I think if we do it like this, we strip those out. So yeah, now the answer is a bit clearer. We have 137 periods, which we can ignore. We have 2 letters there. So let's also just say, okay, something crashes there. So we do boom, const char empty marker equals period. And then we can do hash set char exclude from sparse map is, and we can do empty marker and like this. So now we can make sure that we do boom, 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 where not contains key, like this. Nineberry says, goedenavond. Yes, brings me back to how is that dude called from the Postcode Loterij show? Gaston. It read like that to me. Yeah, goedenavond is good evening in Dutch. So yeah, this is basically that map to a sparse map. We don't count any of the stuff that we don't care about. Let's also just do a map. Map. 2 lines. Map. Let me see, I don't remember which one that I used to do this to create the map dimensions. It was grid actually. Yeah, like this. Okay, got it. We want a grid, not a map. So we have string raw map equals input.toLines. And we make that globally accessible here, or at least within the class, right? So these are everything brought back to the lines. And now we do same here with grid map. And this makes that we can do the bounce checking easily. It's just a little helper. So for part 1, I should probably put this one globally as well, so that I don't have to do that more than once. So we have our grouped collection here, which holds all the things by key, which is a sparse map. So we can do for each for frequency in grouped keys. Okay. And then we need to create permutations of every combination. So we need, oh yeah, we also need to map this still. So we have actually raw map.map as grid locations, I think. Yeah, so this would be the group.keys, like this. So array. So far mapped locations is this would be a sparse map like this. And this is based off of the index order of the keys there. So that's not ideal, but it's fine for now. So we do it like this. So we can do var locations is sparse map, and we need to make sure that we preserve this order actually. So let's say car frequency IDs is this to array. Let's do it like this. Make this global as well. Boom. Yeah, we have that. And now we can do for int I is, or I can just do actually with indexes. So I could do for each and now I can do this is freq.index. So these are all the locations that we have. And then I can do locations dot permutations. Let me see. It's actually 2, false. I think so far. Combinations equals this. So we can do console.writeLine for frequency this frequent value. We have blah freq dot now locations can count locations that count as giving us blah per combinations. So this would be combinations that count. Amate says, I must say Twitch is better at streaming. There's not much delay and it seems to be stable, not growing as on YouTube. Yeah, most people prefer Twitch as a streaming platform. So let's say combination is this length. Oh, it's an IO numeral here. Dot to array. It's fine. Count length then. Okay, so let's run this just to get a feel if my logic is correct. I should probably also write them out just to visually inspect them. 3 antennas, 3 combinations, is that true? Let me just write them out, just so that I feel good about it. For each combo in combinations, console, the outline. So this would be combi dot I think this should be it, right? And these are probably values that are hard to read, right? Let me see. Yeah, I think this is correct. So this gives us all the combinations. And for each one of these combinations, we need to then add 2 values. And we only actually need to validate that basically you could just do a raw function that just takes these values, adds them up. But there could be overlap and it could be out of bounds stuff, so you still have to do the math, so that's fine. Let me see. So you need to subtract them from each other, and then you get the Manhattan distance, and then you need to negate that, and then you have the values for both, I think. Let me just see that I did the math right. So let's see. Basically we have grid location A, comma B. So in this case, A equals combi dot first. B is combi dot skip 1 dot first. Probably could also be a single, but it's fine. So this still becomes A, comma B. I mean, if I go too fast, tell me, because I'm using code that I've written before, obviously. So permutations basically gets the unique. In this case, I specify that I want all unique combinations of 2 values within those set of values. So that helps you give all the unique combinations. Fine for me, says Amate. Okay. Yeah, I just... Sometimes I just get into my own head and I just start coding and maybe not talking enough, so feel free if there's anything that you want me to explain or tell, or if you're like, Nick, what are you doing? What are you working on? Just shout at me. Boom, boom, boom. Let me think. What was I doing? Yeah, I pulled out the 2 values. So the distance would then be A minus B. Didn't I implement this? Ah, okay. So let's see. C equals this, and then probably also because I think we would do like if you do A minus B, that would be the value to add to B. SmapUK says, deja vu today, I've seen a lot of this code before, go faster. Sorry, because I'm just trying to keep my own head straight. So let's see, so we get NA and B, so the new value. So I think NB would be B plus a minus b, right? No. Let's say that this is a, b, so the new a would be a plus a minus b, and I think new b is b plus b minus a, I think. Yes. So that would mean an A and B. Let me just write it out like this, and I don't need, I can probably, let me just set it, I can, it's not that much value, I can just spit it out here. Let me see if my logic is correct. So 1825, that would be, I probably need to draw this out to validate it. Because this one is +1 minus 3. So the opposite of that would be -1 plus 3. So yeah, I think that's correct. 0, 11, and then 3, 2. So I think that is correct. And now I just need to make sure that these values are within bounds. So this one would go out of bounds, this one would go out of bounds, and this one would go out of bounds. So that would be one, actually this one would also go out of bounds, I think. How big was the grid? Was it 10 by 10? Probably, right? Yeah. Actually, I can debug this. 0, like 1, 8, that is this one, with 2, 5 with this one. So I do one at 0, 11. So I think this is off by 1 then. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No, okay, that's correct. It's 11 wide. Was it 11 wide the first time? Okay, so that is fine. I need to make sure that it's in range, but this looks like it generated the correct one, and the other one it would be here. So the 0, 1, 2, 3, 0, 1, 2, 3, 2. So yeah, looks like my logic is correct. So now let's make sure that we keep a hash set of grid location, how did they call them? Let's keep the flavor text in here. Antinodes. I'm usually really bad at keeping the naming going. So let's see, yeah, the antinodes. So now I need to validate that if NA dot column larger equal, actually larger equal 0 and NA dot row. Wait, I can do map is NA that is in bounds, and then I can, yes, map. Ha, that's why I had that. Okay, if this add NA, and we can do if not this console right line there was already an antinode at NA, else I need to add accolades because otherwise it won't know which level else we need. That's the downside of omitting accolades when you have nested ifs. Where does the else go? We can do console.writeLine anti-node would be placed outside of the map at blah. NA. We can do a action grid location try add anti-node node like this. Boom. Now we don't have to copy the same logic twice, so I can just do try add anti-node NA and B. Boom. And we can do P1 equals anti-node start count. So now if we run this, boom, part 1 passes. So it says, okay, we have that many antennas. This one would be placed outside of the map. This one would be placed outside of the map. We have 3 antennas, 1 overlapping antinode, 1 outside of the map, resulting answer 14. So boom, that's fine. Let's do a bool do debug print is false. If do debug print same here. Boom, 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 boom. Boom. Fine. If do debug print. Okay, so now let's run it again. Make sure we didn't break anything. That is fine. Let's do the real input. Boom. P1. 349. Woohoo! First gold star in the bag. Yeah, okay. Thanks. Let's see part 2. Watching over your shoulder as you work, one of the historians asks you if you took the effects of resonant harmonics into your calculations. Whoops. After updating your model, it turns out that an antinode occurs at any grid position exactly in line with at least 2 antennas of the same frequency, regardless of distance. This means that some of the new antinode will occur at a position of each antenna, unless that antenna is the only one that is at frequency. Okay, I need to read that again in a bit. Okay, let's see. So these 3 T frequency antennas now contain create many antinodes. It just repeats forever, okay? In fact, the 3 T frequency antennas are all exactly in line with 2 antennas, so they are all also antinodes. This brings the total number of antinodes in the above example to 9. The original example now has 34 antinodes, including the antinodes that appear on every antenna. Is it just that they wanted us to repeat it, or did I read something wrong? Let me see. Calculate the impact of the signal using the updated model. How many unique locations within the bounds of the maps contain an antinode? It read very confusing to me, but if I look at this, it just means repeat it forever, right? Best description of task at hand ever. Okay. So I wasn't the only one that got a bit confused by this description, or do you mean it's just me? It was the original example. Okay. Hashtag me too. Okay. So I think it just means repeat the thing forever. And I'm gonna treat it like that. Like this. Like this. Yeah, it looks like it. Now it's just better to look at the example. Yeah, I think that's what's happening. It just... Where does this one come from? This one just goes in a straight line, that's fine. I reread it twice. Okay, let me see. So yeah, it just looks like this repeats forever. Because I read it and I'm more confused now, so I think I'll just go with the fact that we will just keep repeating that stuff. But I'm just trying to figure out which ones belongs to, because this one will be there. This one will go there. This one will be that one. That will be the A one. So where does this one come from? Oh, that's a repeat of that one. Yeah, it just means they repeat forever. It's fine. And if it's not, well, we'll cross that bridge when we get there. What did they say? 49? Sure. I also need to put in the actual answer that I had, which was 394. Okay. Okay, so now we do while NA is in bounds map I probably let me not update this. Okay. Boom, 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 boom. So this should now probably hold like a start and an offset, another grid location. So we have start, offset, and we can do while, boom, oh, let's just do this. Node is plus equals offset. Yep. So this will be the new one, and then we do actually so that would be part 2. Let's go back to the test input. P2, I have 29. Okay, that sucks. So I guess we print out all the nodes, all the locations. I can do, I have a print map, map.print path. And this one would be anti-nodes. Okay, so let's see what the difference is. Dun, 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 dun. Should probably just make sure that I think I have a value that also lets me print out the win merge. Yeah, that's also an option, but I wrote stuff for this, so so what I need to do is actually make sure that I do I can just, for now, to do make this configure. I don't want to change the order here, so I'll just do it like this. Boom, 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 boom. I wrote stuff for this. Yeah, it doesn't surprise anybody that knows me. To be honest, this is the part that requires understanding at least one paragraph of the description. Yeah, I've probably failed that because I understood none of it. So first one is good. Second one is wait. Did I need to add the 6 more that I already had? Because I had, let's see, what was my answer? 29. And there are 6 markers here, so that would be 35. So, okay, let's see. Let's go back to this. No. Let's see if there's any other discrepancies there. As for markers, I think it's all good. This one here. That one overlaps this one. This one overlaps this one, but that shouldn't be an issue, right? Yeah, okay, I get it. I think it needs to also have the original nodes. So so I think what it needs is to also have these values. Does that work, the append actually? It's like union with, right? Modifies the current to contain all elements that present in itself, the specialized collection of both. So this would be locations, actually just boom. Yeah, so now it works. So that was the part you also need to add the ones, and one of the things already had a marker, so that's the whole issue. Okay, fine. False. Let's run this again. Answer 1277. Woohoo! We done it. Okay. So yeah, I read a part in the back of my head that like, okay, all the nodes are now also anti-nodes. Okay, yeah. This means that some of the new antennas will including the antinodes that appear on every antenna. Yeah. So basically they say every antenna also counts as an antinode. So, okay. Thanks, Amy. So yeah, this was fairly easy. The hardest thing for me was trying to understand this, but the example does a good job. And then when doing the math of why I was counting low, figured out, yeah, there was an overlap with one of them. So that solves the issue. Yeah. So the fact that I wrote out all these this helper code before previous years really saves me a lot of time and headaches. Because yeah, in the end it was fairly simple if you have all those things lined up already. Yeah, pretty straightforward. Not as bad as I thought it would be. Let's see. Did you post code to the Discord? Nineberry has one. Smap says, I've not seen that one. Started to... Okay. Okay. Smap and Amarte. Okay, let's start with the first submission. Force inline. I love the roughness with the compiler. Basically, this means everywhere it's used, tell the compiler to not jump to this function, but just inline this logic here. I know C# also has like those options, but it's still a suggestion, so I think the compiler can still decide not to do it, but they also have like a very high recommendation to inline this code. Let's see, is within bounds. Yeah, makes sense. Get at. Marta says it's a hint for a compiler. You tell it to really want to, but it may decide. Okay. I thought always that like GCC etc. If you do this force inline, that it will just do it. So it's the same everywhere then. That it's just a very highly suggested thing. I didn't know that in C and C++ you could still have a compiler ignore your wishes there. I thought you had full control over like just do as I tell you. I something in the back of my head reminded me that for at least for C#, it's a suggestion to the compiler and that it may not do it. But yeah, I thought in the lower level languages, and I count C and C++ as lower level languages. Okay. Nice. And that's why I love programming. You learn something new every day. Let's see. Within bounds, get at, all makes sense. So you return the period if it's not within bounds. Okay. Force inline is harder. Yeah. Set at. Okay, so you write your map. Okay. I didn't do that. I kept a separate, well, I kept this. This is also a sparse map, right? No. I kept it separate because I was because it said like they can occur at the same place, and I didn't want to override any of the locations. But yeah, it's basically fine. Because if you pull out all the locations, then use those indices. It doesn't matter that you override the map. Internal location. Let's see, scan for all the antennas. Yeah, this is basically my and if you haven't seen that stuff before, it might be a bit hard to follow what I do here. Like this map as grid locations. I use this a lot for like the multi when there's multiple meanings for it. And I have to say, yeah, I'm missing link a lot. what I used to do, like when I did JavaScript stuff and I missed my link helpers, I would actually just write the link helpers in JavaScript just so that I have the same way of programming there. So that maybe that's something that you want to do in C++ as well. Just write the helpers that you don't want to live without. When you really get down to it, it's not that complicated. But oh yeah, let me see. I want this in previous years. I have a good example, I think. Like if I go bloop. Yeah, like here. So here you have this thing, and there was like garden locations and rock markers. So then I can do the lines, map it. I can specify the start marker, garden marker, and rock marker, which are just constants. And then when I do sValue tuple 3 in the end, I can just map it like this, and then I have my 3 values here that I can target. So it's a semi-nice way for me, at least, to quickly map out all the locations. So this will just run through the entire location once, and then for everything you specified, keep track of a different sparse map. So we'll just, for any amount of characters that you want to map uniquely, it will return a list of sparse maps for those things. So, because usually you want to work with sparse maps in Advent of Code anyways. But we weren't looking at my code, we were looking at your code. Let's see. Antenna map location. Sure. Is there a reason why you do this instead of an if? Is that just a style preference, or is there any other benefit? Maybe because of the compiled code doesn't have to branch off, or... Okay, just a style. I was wondering, like, if I think about how it compiles back to more like assembly, how this would unwrap. I don't spend much time usually thinking about how it would work in the lower level, but reading the code like this, it like makes me think about, yeah, maybe this is a more efficient way to just have like a jump here and just have the normal execution flow be here without any... let's see, the simplest way to hold antenna bitmap. Bitmap? When I read bitmap, I always think of like a BMP. Normally I use accolades with ifs. That's a lot of new lines, so continue takes less space. Sure. So enumerate the map here. Antenna type, antenna map. What did I miss here? What is the antenna type dot second? Is that just the Y here? No. Antenna location, antenna map. Yeah, this, like the first level would be the rows. This one would be the columns, right? And then extend, sure. Antenna type is a pair of char, antenna mark, and second is a list of all locations. Ah, okay, sure. Yeah. This is all the same until here. And this becomes a while loop. Yeah. Yeah. Basically, this. I mean, there aren't many ways to do this, right? But yeah, looks good. This was SMAP. Let's see what SMAP made. A two-dimensional array of char. Let's see. Load map. for each cell. Okay. Is ASCII letter or digit? Okay. So the period doesn't matter there. Yeah. Okay. So you filter out those, and then you do the lookup. I assume this is in an extension. This one will give you is there an extensions thing here? What namespace is open? Solution is this. My cell type has a value in index. And index, is that just because it's a multi-dimensional array? It will be just a row and a column, I assume. Okay. My helpers are in a different solution as new. Ah, okay. That's fine. Makes sense. Is there a reason why you go to 2D array and not just a list of string? Because basically a string is already like a char array. Just wondering. But yeah, basically you map them all out. Just thinking if there's a better way to do this, because first you map it out, then you enumerate it again, and then you filter all the indices again. Yes, I want it for the visualizer. Okay. And then you keep, so basically this becomes a sparse map. Visualize map. Do you have a screenshot? Let's see, part 1. Antinode is get antinode, sure. What does this do? The start one? Get antinodes. I can probably look that up here. It goes to my debug output. Okay. Feel free to post a screenshot in the, or is it just like a console dump? Well, it makes sense. I just always like to see the visualizations. So the difference between these two is here you pass a 1 for start and here a 0 for start. So I assume we'll I wonder what the difference there is. Let's see. Get antinodes, I look up antenna from point. So this start here, let's see. The combinations is basically the permutation thing. Literally just the grid you see in the description. Yeah, I just wonder why the start is different here. Like start 1 and start 0. I was trying to see what that does. Didn't caught that here. N is start, N++, all of bounds. Wait, that's my old code again. It just points to the actual file. Let's reload. Okay. Where are we? Should be permutations. Yeah, permutate here. Permutate 2. Boom, 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 boom. Start. Yeah, is in bounds. Sure. Otherwise, break. Ah, okay. It's a bit, everybody to each their own, right? But to me, this reads really, it's a weird way to do like the looping stuff, right? So you have basically a variable here. If it's 1, then you break, and otherwise you get just basically the infinite loop until you go out of bounds. So why not just pass in a bool? Like, I wonder what the choice is there. Because basically it's a boolean for like, okay, just do the single in 2 ends, or keep going till you're out of bounds. So the way of passing like a number and let's see, I would need to change the start if it was a bool. What do you mean, need to change the start? Yeah, but the start is only used to break here. So it's basically the same as a bool. Or maybe I don't understand. No, the loop starts in a different place. It's also the starting point for the loop. Ah, it's the it's the this. Ah, okay, never mind. Okay, sure. Okay. The visualize. Okay. 9 says in part 1 the antinode is vector times 1 away from the satellite. In part 2 the first antinode is the satellite itself. Okay. Let's see what Nineberry made. Maps the bounds. Creates a sparse map. Yep. Pretty straightforward. Let's see. Within the loop, I only go into one direction, so you need both A, B, and B. Yeah, but that's the way how you set this up. You didn't do a lot of pre-qualification, but that's fine. You just have your exit clauses here, so works just as well, and probably is easier to read as well. So that's something that I noticed from all your solutions. They are maybe not per se advanced, using lots of tricks, but everybody can read it, and it's clear and not a lot of noise. So I always really like seeing your code. It's hard to make it look easy, right? And you do that every time, so bonus points for that. Yeah. Let's see, what do you have? A record point here. Get standard factor 2. Oh wow, what is all of this? I don't think any of this was needed, right? Oh, you do that. Wait, what? Okay, I think this might be a little bit more complicated than it needs to be. But other than that, nice. So yeah, I think that was all the submissions. So I think we're done early, and I can bring the kids to bed actually. I was preparing for a long stream where I didn't have time to read the kids today, but yeah, plenty of time. So I want to thank everybody again for keeping me company. It's always nice to have you here. I expected a more difficult problem today, but we'll probably get a difficult problem in a few days. Usually they save that for the weekend, and yeah, this one was fairly easy. Especially if you've done Advent of Code before, you will have lots of helper code to just make things even easier. So yeah, it was a nice little ending to the weekend. So yeah, I want to thank everybody for keeping me company. I'll round it up here, and yeah, probably should rate somebody on Twitch. Let me open twitch.tv. Let's see who's coding. Let me actually do that on this screen so that you can see what I'm doing. Let's go to twitch.tv, and not my chat, but let's mute myself here. Let's see. Honest Dan is coding. You should probably look at somebody who's doing Advent of Code, maybe. Advent of Cyber. Advent of Code day 8. Let me mute my audio here so that I can enable my audio. Let's see. Okay, I've disabled the, what do you call it? Spotify, damn. Let's see. What was I doing? Okay, let's try this one. Do I have audio? Is there a rate button, or do I still need to manually do that? I can probably just... it used to be like a command, I think. I think I can just... There was like a command. I can just type it here, I think, like rate... like this. Bij Vattenfall zetten we stappen om minder afhankelijk te worden van fossiele... Yeah, okay. So let's do that. Okay, I think that should be it. So yeah, thanks everybody. Go have fun, maybe watching somebody else do more Advent of Code. And then we'll see you tomorrow. Bye bye.